Hi. Listen, I'm working on a Saturday. I got to make it fun. So this is Math 7 3-8 example 2. And this has a part A and a part B to it that we're going to look at. So example 2 gives us an expression, negative 7x plus negative 49xy. And part A is asking us to find the GCF. Remember that GCF stands for that greatest common factor. And remember that factors are just things that are being multiplied to get us there. So in example 2, what is the greatest common factor? So if I look at those two pieces, when I'm doing that, I'm looking to see basically, when it's asking me what the GCF is, oh my goodness, okay. It's asking me what do both, keyword, both pieces, and actually instead of calling them pieces, we're going to use the real word for them and call them terms because big words make us sound smart. So what do both terms have in common? What does that negative 7x and that negative 49xy, what do those pieces have in common that they share? Well, if I'm thinking about factors, the only factors of 7 are 7 and 1. But luckily, I know my facts a little well, and I know that 7 goes into 49. So my greatest common factor is definitely going to be 7. But here's the thing. It's not just 7 because, as we said at the beginning here, variables can be factors. So we're going to make a little big note of this. Remember that variables can be factors also. And we're going to see a bunch of that in this lesson. So if I'm looking at the variables here, what do both pieces or both terms have in common variable-wise? And you can see that that would be an x. They're not like terms. That's not what we're saying. We're not saying that these two pieces are like terms and then I can add them together because that's not true, right? One has a y and one doesn't. All we're saying is that both pieces do have an x and they have that in common. So we are able to take an x out of both of those pieces since they both have one. We wouldn't be able to take a y out of both pieces because the negative 7x doesn't have a y for us to take out. And actually, there is one more other thing that both of these pieces have in common that we could take out of them, and that would be the negative. Both of those pieces are negatives, so we can take the negative out of each one, and that gives me a GCF of negative 7x. So then part B, asking me what is the factorization. Remember, when they're asking us for factorization, that just means they want us to take out the GCF or factor out the GCF. Make a little note of that real quick. They want us to factor out the GCF. So this problem kind of broke it down for you, part A, part B, kind of like step 1, step 2. In your practice problems, you're going to be doing a lot of this together. So factoring out the GCF, let's take a look at that. I'm going to zoom in a lot here so I have more room. Okay, so let's do this in purple. So if I'm looking at my negative 7x plus negative 49xy, when we were taking out that GCF, we're doing the opposite operation of multiplication, which is division. So really what I'm doing is I'm dividing both of these pieces by that GCF. And let's just make a note. Remember, this negative 7x is my GCF. Also, remember that that GCF needs to stay on the outside of those parentheses. So I'm going to come down here right away, and I am going to take that negative 7x and put it on the outside of parentheses so I don't forget about it. So now inside my parentheses, if I have negative 7x divided by negative 7x, well, that's like having negative 7 divided by negative 7, or 1 divided by 1, or 10 divided by 10, or x divided by x. All of those things just give me 1. So we have a 1 left. It can't cancel out to be nothing because there isn't nothing there. 7 divided by 7 is 1, not 0. So this simplifies to 1. And then over here, my negative 49 divided by negative 7, well, negative divided by negative is a positive. 49 divided by 7, you could jump to your calculator here. I know that's 7. X divided by x is going to cancel out. And I'm left with just a y. So the factorization of this is, boom, that guy right there.